Hello all. I'd like to thank you for joining our session on Android application hacking with damn vulnerable bank. So this is how the UI of our vulnerable bank is. With the huge number of Android applications and the frequency with which we use them, it is more important than ever for us to understand the security of Android applications and their pitfalls. We have many ways to learn and practice Android application security as of today, but most of the applications which you have cover only the basic OS top 10 vulnerabilities, which are common in 2010. None of them are updated to the standards of the latest dates. So we would like to cover this gap and take the learning curve a notch higher with our damn vulnerable bank. This not only allows you to assess your theoretical skills, but it also goes beyond regular OS top 10 vulnerabilities. It expects you to know more about Android internals, how the applications are built. You have to do binary analysis and a lot more. We are sure it pushes you hard to the next level, whoever is getting started with Android application security. Without further ado, let's get started. So this is the outline of this talk, an introduction to our core team. Why Android? Why Android applications? Why did we choose Android application security? Threat vectors for the Android applications, introduction to our application, hands-on session, closing notes, QA. So the core team, myself, Rewanth Tammana. I'm currently a senior security architect at Emirates NBD, speaker and trainer at Black Hat, DEF CON, Hack in the Box, etc. I'm an active open source contributor and I have added 17,000 plus lines of code to Nmap. And the other key member of our core team is Akshansh Jaiswal. He's a security engineer at CRED. He's an active CTF player. He won several CTFs including HackerOne, Hacky Holidays, and so on. He's also a CNAC Red Team member. Last but not least, we have the Hrushikesh Kakade. So he is a part of Bandit specialized in advanced security assessment, and he's an active CNAC Red Team member, OSCP certified, and also an open source contributor. So why Android? Why did we choose Android? Android is everywhere. Across the globe, you find it. So you can find Android in automobiles, refrigerators, mobiles, gaming consoles, home automation, VR, OS, Nintendos, everywhere you'll find Android. And if you see, Android has been growing without leaps and bounds since its inception. It started out with Cupcake, Donut, but it gained more traction once it released Jelly Bean. That's when the smartphones got more cheaper and the processing power of the mobiles got increased. So the Jelly Bean, Kit Kat, Lollipop, Marshmallow. That's when Android got more traction than ever, and we got more developers building a lot of applications. And the trend continues to go on, and Android devices and the applications keep on increasing. So according to the stats counter from July 2021, they say 72% of the devices across the globe are running Android. So this is one of the reasons why we picked Android, because it creates a huge impact. And even the iOS is also having a significant contribution of 26%. And there are some other operating systems which are considerably minimal. So you see the growth of Android in 2009 it started, but it was growing very slow comparatively in the 2013-14 where we have the Marshmallow, Jelly Bean. It started out with Jelly Bean until Marshmallow. We had a huge surge in the number of Android applications. So as you can see from the statistics of Dataflare, by 2023 there will be around 87% of the devices running Android. So Android is not just limited to mobiles, the IoT, automobiles, everywhere. And why did we choose the Android applications? As you can see, in 2012 it started out, and when you compare the iOS and Android, there was not much difference. It's just about a 0.1 million difference. But when you see about 2013-14, where we got the Jelly Bean, Kit Kat, and the other versions released slowly, we can see the number of we can see the increase in the number of applications for Android on Google Play. If you see on 2017, we have around 1.6 million apps on Google Play, whereas in iOS it's just 0.75 million. As of 2021, there are around 4 million apps on Google Play. And yeah, this is a statistics from BuildFire which confirms these facts that I validated. There are around 4.2 million applications as of 2020, and as of 2021, it's even more. And the games play a key role in Android applications, and the remaining regular applications which we use on the daily basis for the sportswear, fintech, health tracking, cooking, entertainment, and the list goes on. So just imagine 4.2 million applications, and its security is more important than ever. So why Android application security? As we have seen, there are around 4 million applications, and people have been using that across the globe. And an attack on one of such applications will create a huge impact. So the malware attacks in Android, according to Checkpoint, as you can see, the malware attacks are targeted mostly for the financial leverage. Around 29% of the attacks happen in the financial industry or the fintech applications. That impacts a lot of things, and the government applications, manufacturing, technology, and so on. Also, you can see the growth in malware infection is significantly higher. When the Android started, it was just 12 million devices or applications that got compromised, and as of 2018, there are around 800 million and more infected applications. So if you consider about 2021, it will be even more higher. So it's very important for us to understand the core concepts of the Android application security, or how we can protect them from a security point of view. And yeah, as you can see, in 2006, when everything got started, all the attacks were non-profit motivated. They were just leveraging the vulnerabilities for fun. But as we got later into the other era, we got introduction to the bitcoins, cryptocurrencies, non-traceable transactions, and so on. So that's when things changed, when the fintech applications started getting installed on our mobiles, where we can make transactions in just one click. That's when the attackers moved from non-profit to profit-motivated attacks, where they do spear phishing attacks, or they target particular individuals or a particular application to exploit for money. And as you can see, in 2012, there are around 173 attacks that happened for the profit-motivated, and that's a significant trace. So we are sure if by 2021, as of now, it's even more. As you can see, high-risk vulnerabilities found in 1/3 of the Android applications are nearly equivalent to half of the or 50% of the Android applications. And according to the HelpNet Security, 60% of the vulnerabilities in Android applications are on client side itself. And that should be something very scary about. And 89% of the vulnerabilities can be exploited without any physical access. So just your Android application and an internet access, it's enough to create a huge loss. And also 56% of the vulnerabilities can be exploited without even administrator rights. So even if some attacker gets hands on your mobile, he doesn't need to jailbreak or do something. Just with the default privileges, 56% of the attacks happen. So this is where we believe, considering these huge significant numbers, Android applications should be protected. And threat vectors for the Android applications, as we have discussed, the malware, data exfiltration, data tampering, data loss, multiple threat vectors depending on the kind of applications we are seeing. And considering the huge number of 4 million plus applications which we have, they have different features, and we'll get to have different threat vectors. But the most common ones are these listed here. And what are the consequences of these threat vectors? They can lead to losing of your data, bad use of your mobile resources, maybe a crypto miner running on your mobile, and reputational loss, identity theft. They can use your mobile to perform some DDoS attacks. They can use your mobile for multiple other purposes, and which can create a huge impact for you on the professional and personal level. So this is what we strive to do with our damn vulnerable bank. With these significant numbers and the increasing rate of the Android applications and the lot of new developers to the Android, we want to provide a platform where the people who want to get started with the Android application security or the Android developers have an interface to learn Android application security at a deeper level. All the applications which we have today, they just cover the OS top 10 vulnerabilities, but we want to take it a notch higher and focus on the recent vulnerabilities which we see. And we want to make it realistic as possible. And that's where this damn vulnerable bank comes into play. As you can see, we have the complete banking interface, the sign up login similar to the real world applications, and for making a transfer, adding the beneficiary and stuff. So I won't take much of your time. We'll get immediately started with the demo, and my colleague Hrushikesh will take you further on this.
Thank you, Rewanth, for a quick introduction. Let's start with installing the application using the adb command. So adb install dvba.apk. Okay, looks like we have installed the application successfully. Let's go ahead and open the application. Looks like the application is crashing. We need to find a way why the application is crashing. In order to do that, what we can do is we will decompile the application using the APK tool and check the Android manifest file. So let's go ahead. We'll use the APK tool D to decompile, and we'll take the APK file and let's decompile the application. Next, we'll go to the section where the Android manifest is, open the Android manifest file, and we need to check the section called as hardware accelerated. So why we are looking at this is because we are running the application right now in an emulator, and the emulator does not need a GPU. And since this is set to true, it means that the application will be using GPU, which is basically crashing the application. So what we can do is we'll go ahead and set this value to false. Now, before closing this Android manifest, what we could do is just copy the name of the package which will require it for the later use. Alright, I think we are done over here with the Android manifest. We will close it, go back, and compile the application again using the APK tool, which is APK tool build, that is B, and then again the name of the folder followed by a new application name. Let's wait for a few seconds so that it builds the application, and the application is built. Now what we will do is we will go ahead and uninstall the previous application so that we can install this new application. We'll use Adb Uninstall, and remember we had copied the package name. We'll quickly paste it over here. Apparently I copied the other command, so I'll have to just quickly go to this section, copy the name of the package, and then adb uninstall the name of the package. Now we have uninstalled the application. We will go ahead and install the application that we just now built, which is dvba-no GPU. So adb install name of the package. Just trying to install the package, but looks like there is some error. It says that failed to collect certificates. Now we are getting this error because we have yet not signed our application. So let's go ahead and sign the application using the key tool. So key tool will create a key first with the type key store, and let's set up a password for the key tool. We can keep it blank. Click on yes. We have created a key. Now we'll use this key to sign our application using the jar signer. Let's go ahead and sign our application. Let's use the previously set password for the key, and we have signed the application. Now what we'll go is we'll go ahead and install the application using the Adb Uninstall -no GPU, and it says success. Great. Let's go ahead, open the application and see if it's opening. We are now able to open the application, but wait, we are now getting some other errors. It says that phone is rooted and the emulator is detected. What we can do now, let's reverse engineer the application using a tool called Apkx. So let's go ahead, type in Apkx, the name of the APK that we are using right now, which is no-GPU. What it will do is it will decompile the application, and then using this, what we are going to do is we are going to look at the source code, and then from that we are going to find out what exactly is making the application close, and exactly what code block is giving us those toasts, which is the emulator detected and the root is detected. Let's wait for this tool to complete. Alright, we can see that the decompiling is done. Let's go ahead and check the folder dvb-no GPU. We'll go ahead and open this in one of our favorite code editors. Here I will use the VS Code. But wait, searching from here is a tedious task. What we could do instead is let's use a command line tool called grep and look for the word which said emulator detected. I'll just quickly show the application again, and we'll check the toast. What message does it give? It says emulator detected. Let's go with that. So I'm using a -i flag for case insensitive and R for recursive, and let's check for the message saying emulator detected. Great. We have found the name of the file, which is in src-com app, a damn vulnerable bank folder as well. Let's go ahead and open that. Set src-com app damn vulnerable main activity.java. Now what we could do from here is let's search for the keyword emulator, and there it is. We have found the code block that is actually giving us the toast, but this code block does not seem to actually close the application. It is just sending a toast. Now let's check for the other message, that was phone is rooted. Here it is. So basically we are looking at this code block. Now what exactly is happening? If the a.r returns true, the application will send a toast with the message phone is rooted, and then it will call the function which is this.finish, which will basically close the application. Now in order to bypass this checks, what we have to do is we have to flip the return value of this method. Now there are two ways to do that. One is to patch the application using Smalley code and then rebuild and then reinstall. The other way is to dynamically hook into this function at the runtime and change the behavior of this method and send the value as false instead of true. Or we could just flip the value of a.r. So we don't even have to see how the a.r is implemented. Now in order to do that, let's go ahead and let's use Frida to dynamically hook onto this method. So I'll close this file, which we won't need right now. Okay. Now what I'm going to do is we already have a script ready for Frida. I will just quickly show you the script that is we are going to use. Let me just get back. There it is. So what we are going to do right now is java.use is going to use this package called a.a.a.a, where the a.r is actually defined. Now we are going to implement the method r, which we saw previously, wherein a.r was being used. What we are going to do is we will be going to call the method as is without modifying. We will get the return value of this method, and then what we are going to do is we are going to return the exact opposite value of the return value. Before that, we will print the value. Now this is a JavaScript code which we will be using. So how do we use this? Basically we will be using Frida to execute this, and this will also open the application. Alright then, let's go ahead and run Frida to start this. What I'm going to do is I'll be calling a Frida command with a -f, which will open the package, and the L will pass the file name which we just saw. Okay, let's see how it goes. Clicking on insert. Alright, looks like I have not started my Frida server. Let me just go ahead and let me just start the Frida server. This might have gotten stuck. Let's open a new terminal and let's try the same Frida script command. Okay, it says syntax error. Let's check what the error is on the line 10. Let's try and change it to var. Let's execute it again. So let's run the Frida script and see if we can bypass the root detection and the emulator detection using this. It says use resume to let the main thread running. Okay. Now what we are seeing over here is we can ignore the emulator is detected, but we are seeing that the Frida is running. This is what we are seeing now, and that is what is crashing the application. Let's go ahead and see exactly what that is. Let's check the code again. Alright, now we have bypassed this. Phone is rooted. Now what we have to do is we have to bypass the Frida is running error, which is basically causing the application to stop. Now how do we do that? We need to first figure out how exactly what this Frida check is. Now how do we find that? The code is already obfuscated. We cannot just go into the code and keep on looking. That will take a lot of time. What we can do again is use grep ir and let's grep for Frida. Now we have got many matches over here. What we can check for hints is Frida check JNI. We could check load system.load library for Frida check. We also find over here Frida check JNI, which is basically, and also over here something like lib Frida check.so, which is basically giving us some idea that there is a chance that we are looking at a native library, which is a .so file. Now how do we find how this Frida check is implemented? In order to do that, we are going to use a tool called Ghidra to reverse engineer this library and see what exactly it is doing. So let's open Ghidra. And let me just transfer the file into the Ghidra. Now we know that what we have to do right now is, since we are using an emulator, we have to find a file of x86, since the emulator runs on an x86 architecture. So this is the path of the file that we need to get. So what I have done right now is I have drag and drop this file in Ghidra. I'll just click on OK. It will load, and so basically it will give us a file browser. Sorry, my bad, code browser. Now what we can do is we can go ahead and click on functions and check all the methods. The method that we are interested in is this. This is java _com_app dam vulnerable frida check jni. Now binary analysis is out of the scope over here, so we won't be focusing a lot. But if you look at the code on the right side, it is basically a reverse engineered code for a socket connection. So what is happening over here is the socket is being created, and this local 28 is being passed for connection. Now as we can see that local 28 is actually a constant over here. Now what do we understand from this? So in most cases what happens is the binaries contain code in the big endian format. So we basically need to convert this value, which is A269000002 to an actual value, which is having 8 bits. Now basically we have to split this into halves, which is 0x A269 and 0002. Now in order to convert them from big endian to a decimal value, we have to swap the first two and the last two bits. So basically a 0x A269 will become 69A2, and which is equivalent to 274. Basically it is equivalent to 27042. So if I could just see if I can convert this value directly to decimal, if I can show you right over here. Yes, so what's happening right now over here is that we need to swap the digits, which is why we are not able to get the exact value which we wanted to, which is 27042. Now if I click on convert again, so this is the problem, but I hope you got it. Basically what we are saying is that since we have to convert it from big endian, we have to split the first 4 bits and the last 4 bits. So we have let's focus on the first 4 bits, which is 0x A269, which will be changing as 2A and 96. So it will be 0x 2A 96, which after converting to decimal would be 27042. And now if you Google the Frida's default port, since Frida is a server client architecture, Frida server is running on the emulator. Now if you Google the default port of the Frida, we'll find that it is 27042, which is the exact port that we have found. So what do we understand from this code? It is basically that the application is trying to connect to the default port, and if the port responds back with a TCP handshake packet, basically it will find that the port is open and the application stops working. So how do we bypass this? Well, it's pretty easy. All we have to do is just change the port of the Frida server. That's it. Now how do we do that? Let's see. Let me just close the Ghidra. Alright. Now let's go ahead and get into adb shell, cd data local temp. This is where I have stored my Frida server. This is my Frida server. What I'm going to do is I will kill the previous the current process. Let me find what the process is. Which is 4706. Let's kill that first. Now let's start the Frida server again. Now what we are going to do is we are going to run the Frida server on port 1337. Let's see how it goes. Alright, now that we have started the Frida server on 1337 port, let me just change the terminal over here and let's try and connect to this Frida server. Now how do we execute the command now? Well, it's pretty easy. We just have to add the -h flag. So how do we do that? First, get the IP address of the emulator, which is, in my case, it's 192.168.57.107. Let's go ahead and run Frida, this time with a host and the port number that we have given, and the rest of the flags remain the same. Let's see how it goes. Listen. Resume. The application is opening, and finally the emulator detected and the Frida is not running. That's great. Now we are able to run the application. Now let's try and understand and explore the application. Now that we are able to run the application, let's go ahead and try and explore the application. In order to do that, what we have to do first is start the backend server and then get the IP address where the backend server is running and enter the IP address in the API input field. I went ahead and checked the IP address where my backend server is running, and I'm going to put that over here, which is 192.168.57.1 and 3000. So 3000 port is where the API is running. Let's click on health check and see if the API is up. Great, the API is up. I'm going to go ahead and use the login feature to log in using one of the default credentials, which is user1 and the corresponding password of user1. Alright then, looks like we have logged in finally. We will have to keep this Frida running because without that the bypasses won't work, which means the application will crash. Now the next step is we need to understand and see how the request and response is being handled. So for that, what we are going to do is we are going to use burp to intercept the requests and then see the traffic, how is it flowing. Now how to set up burp and proxy is not in the scope, so I'm going to just go ahead and show the response and the request from the burp. Alright then, let's go ahead and let's click on view beneficiary. We can see that there is a request and response that we are getting by clicking the view beneficiary. In the request, we are not getting any much of a body. It's just a post request to view the beneficiary. The authentication or the authorization is implemented using the JWT token. Now, even JWT token is out of scope right now since we are focusing more on the application. Let's check the response. Okay, then. It looks like the response has the keyword. So the first thing is that the response is in JSON format. Second is the key is enc_data and the value is not in plain text. It looks like a base 64. So let's just go ahead, select this value. We can check in the decoder, decode as base 64. But hey, everything is garbage. It looks like it's probably encrypted. Now what we can do is since we are checking at the beneficiary view, we can just go ahead and check the source code of it, and we'll find what exactly is the application doing. So to do that, let's open the application that was previously decompiled using the Apkx tool. So we will open it using the VS Code editor. So let's say we are checking the view beneficiary. Let's see where view beneficiary is. Okay, this looks like a function which is using view beneficiary. Let me just minimize my work. All right. Great. I hope this is visible now. Okay. So now let's check view beneficiary. Let us again check what exactly did we find in the birth. The keyword. It was enc underscore data. So let's go ahead and check for the keyword enc underscore data. We are not finding anything under enc underscore data. No worries. We can go ahead and check view balance. And hey, I think there is one finding where the enc underscore data is being used. So what does this line say? It says that it is getting a JSON object from the enc underscore data. It is taking the body or the value of enc underscore data and it is passing to a function called e.a. Now we need to find out what does e.a does. It looks like that e.a is decrypting the value that is being sent by the enc underscore data. Now how do we find that? So the package that is being imported is c.b.a.e. What we could do is just get into c.b.a.e. So this is the package that we are looking at, and then the function with the method name a. Again, then there is another function that is being called. Let's not get into the rabbit hole. What we could do is just use Frida magic again and just hook onto the method which we saw previously in, let's say, view balance, which was e.a. So this is the script that we'll be using to get the decrypted value. So what we are doing here, we are using the package which is c.b.a.e, which we saw previously. We are implementing the function which is a, which means that whenever this function a is called from the package c.b.a.e, this is the method that will get executed. And what are we doing here? We are just getting the data that is being sent to this method. We will actually call this original method, get the return value, which hopefully should be the decrypted value. We'll log it, and then we'll just return the same value so that we do not crash the application. Alright then, let's save this. Let us go ahead and reload this script. Alright then, looks like we are getting the decrypted value as well. That is great. But now we also need to see the value that is being sent to the server. So basically we need the value that is being sent to the server so that we can tamper with the request and then go ahead with our other pen testing methodologies or strategies. But first, let's see how we can tamper the request. For that, first we'll have to decode or decrypt the requests. So in order to find how the request can be tampered, we need to find an API that actually has got the requests. So let's just click on few of the APIs over here and see if we can find any API that actually has got the request. Well, this does not have one. My balance does not have one. Transactions, no. We get one for so let's go ahead and transfer some money, see if that works. Enter the account number again, which is 3 times 2, 3 times 2. Enter the amount. Let's just send 1. It has not found any fingerprint sensor. I hope it goes ahead, and it won't. This is because we have not implemented a pin. If we had implemented a security pin, this would have gone ahead. Alright then, looks like we are not finding any method from here. Let's just go into the source code and see if we can find any method. Let's check bank login. Alright then, looks like this is something that is interesting. It is taking username and password. Okay, wait, this is something we had found in the burp as well. If you check login, the request is actually sending some data which is encrypted. Let's try and leverage this. So here the username password is being sent and it's being put in enc_data as a key, and e.b method is being called before sending this JSON object. This is the JSON object that was created. Now this e.b could be the function that is used to encrypt the data. So how do we do this again? We already know where the method is being, which is in. So e.b is a part of c.b.a.e. Now we won't go into the rabbit hole again. We will just write a Frida script to decrypt this value. As you can see here, this is the method that we are using to decrypt the encrypted value. So we are again using the same package, which is c.b.a.e. This time we are implementing the method b. Last time we had implemented the method a, which was the decryption method. This method is used for encryption. And now what we are going to do over here is we will get the data, the original data before encryption, then we will be encrypting the data, and then we will be logging it again, and then we will return the data as is so that the application does not crash. So let's just save this file. Let's close it, or we could keep it running. Let's come here, just a few enters so that we do not mess up. Let's reload, and now what we could do is we could log out. And login user 1 and password 1. There we go. We are able to get the decrypted data. Now let's understand how the encryption and decryption is working, because we cannot keep on doing this. If we have to tamper the value while sending the encrypted data, we need a code on our local site that will easily encrypt and decrypt for us. But in order to write a local code, we'll have to understand how the encryption decryption is working in the application. Now we know that the method e.b is being called, which is the package c.b.a.e is being used for both encryption and decryption. So let's go ahead and check that package. So what I'm going to do is I'm going to visit c.b.a.e, wherein I can see that the method A was used for decryption, the method B was used for encryption. And what is common in this? The common is method e.c, which is e.c, which is being used. As you can see in the decryption, what it is doing is it is passing the base64 decoded value to e.c. While in method B, as you can see over here, it is first passing the value directly, which means that it is a plain text value, and then base 64 encoding. So let's see what this exactly is. Now, the logic that is being used for encryption and decryption is not a part of this and could be done as a homework. What we are going to do is we'll basically understand what exactly it is, how exactly can we implement this. Now we can see that there is a hard-coded key that we can use, which is being used as well. And then there are a few operations that are being implemented. Now what we are going to do is we are not going to go into the depth of the encryption, but let's say we have written the encrypted and the decrypted code on the local side. Once we understand how this encryption and decryption is working on the application, so how easy would it be just to decrypt this application or decrypt the entire traffic? Let me just spin up burp again. So here we can see that, let's say we take this encrypted data and we try to decrypt it. All we have to do now is just copy this data and we just have to paste it in a, we just have to call the decrypt method that we have written after understanding or after reversing the decryption and encryption method from the application, and we just copy it over here. We save this and then we call the script, which is using node. So we have written the code in the JavaScript. So let's try and execute this, and there you go, we are getting the decrypted value. Let's try another one. Let us take a response this time. We copy the encrypted data, we open the crypto.js, we change this value, save the file and execute it again, and there you go, we have our decrypted data. This is how easy this has been once we understand how the application is reversed. But it's not going to be that easy in the real world example. Now, to take you ahead, I invite Akshansh and I hand over it to him. Thank you.
So in exploit section, we are going to talk about real world attack scenarios and vulnerabilities in DVBA. So let's begin with real world attack scenarios. So first we are going to discuss about sensitive information disclosure. So in this, we are going to talk about a researcher report that was being disclosed on HackerOne, and the application was Coinbase. So in Coinbase application, there was a bug where logging was enabled, and which would result in the highest impact for access token leakage. So basically, when a user would log in into Facebook, the OAuth response code would be sent back to the application. But in this case, what was also happening is that the application was receiving it, but also the logging was enabled. So via logcat, anyone could also see that response code. So researcher further escalated and was able to obtain the access token for an account by also using client secret. Coming to second vulnerability, there was user input leakage. So this happened in Grammarly keyboard application. So in Grammarly keyboard application before 4.1, there was leakage in user input text field. But currently, Grammarly keyboard is not supported less than version 5.0, so the vulnerability is itself prevented. Third, we are coming to excesses in WebView. So this was reported by Paggy Pro and in Grab application. So in this, the issues were related with deep link and WebView. So what basically the issue was that deep link was accepting page URL parameter, and this parameter was able to load URL in the application. So Once it was loaded in the application, user can send a deep link URL and it would be loaded inside the application sandbox. So Baki Pro further escalated it, and then he was also able to get grab user information. So for a particular user, he was able to get information of them. So how this was exactly triggered, let's see. So as you can see, like, the page parameter was vulnerable, which was able to open any URL. Now once this could open any URL, the first major attacks can be the user can do an open redirect and can send him to a malicious web page, or they can show an pop-up or alert kind of thing. But in this case, what was happening is basically the WebView had an interesting setting that would support Zendesk activity web interface, and basically this what allowed is to get grab information user within that web page. So basically for the POC, if someone had loaded window.android get grab user and loaded this exact page, what would happen basically is they could get grab user information. So this was a sensitive one which was happening via accesses, and also the deep link was involved, so this was a chain of multiple issues. So now let's look at vulnerabilities that we have laid out in DVPA. So we are going to see demo for two of the vulnerabilities, that is first sensitive information disclosure and accesses in WebView via deep link. So let's start with this. So first we are going to see the sensitive information disclosure, that is we are going to see how we can get an access token from the application. So here let's first look at the activity. So in bank login activity, which is the login page for our application, here once a user login, basically the application also login for access token. So basically one can read the access token via ADB logs. So let's see the demo for same. So we have our application here, and let's do login, and we are going for the admin user account, and let's grep for the access token and let's login. So as you can see, we got the admin user access token via the ADB logs. So this was an issue where the application is logging, which it should not, and because of that we were able to get the access token and see the admin account. So while using this, basically you can also log in as admin. Now second, we will see an access issue that exists due to chaining of WebView and deep link. Now let's look at Android Studio again, and let's look at the code for Android manifest. So in manifest, if we see, we have currency rates activity, which basically accepts a deep link. So this deep link is a URL basically where the scheme is HTTP and the host is sexy.com. So basically here the application expects that a deep link with an protocol HTTP and a host xp.com can be accepted by this application. Now let's see how this deep link will be consumed by the application. So if we open currency rates activity, we see that the deep link has two ways to being accepted. The first being, if the deep link is null, it would directly open xc.com, but if there is a URL parameter attached to it, then it would load that URL basically after the URL parameter, the value of that. So just giving you an example here, if we have https www.xe.com comma URL equal to https google.com. So if we see here, google.com will be opened if we send this URL to the deep link. Now let's see what the potential impact can be of this. Now we have seen that we can send arbitrary URL from our side which we can send it to the deep link. Now using this, we can get an open redirect, but let's see an XSS example. So what we can do is basically load a web page. We can open it in Chrome or in via file also. So under this, what we'll do is basically first add xe.com, that is the protocol and the host, then add the URL parameter, which will help us to pass the other half, that is other URL for that, and then we can execute the JavaScript as well. So let's see the demo for same. So as you can see, we have loaded this page, and if we click on lucky draw, let's see what happens. So we get the prompt and we'll click just once. As you see, we get the JavaScript being executed and we get the prompt for enter password. Now this was the demo for the two vulnerabilities that we have covered.
Thank you, Akshansh and Hrushikesh, for the wonderful session. I hope you have got some idea on what we are trying to achieve and the kind of vulnerabilities which we have integrated with the vulnerable application. So just a closing notes. So with this all said, we developed this application, the Damn Vulnerable Bank, with the willingness to share, learn, and teach Android application security. We want to give the community what we didn't have when we got started. Just knowing the OS top 10 vulnerabilities will not help us in the long run or when we try to pen test applications at large scale. So we want to provide an interface that will help you while doing the real world pen tests as well. So we are constantly striving to keep this application updated with the latest vulnerabilities and make it as harder as possible to level up the skills of the beginners starting with Android application security, so that they will have access and knowledge to different techniques other than OWASP top 10. And as you can see, we have the GitHub link and over there, and we have a complete guide on how you can solve all these challenges with a complete walkthrough as the below link. And yeah, we are open for the Q&A, and you can contact us on Twitter on this below links. Thank you for staying with us so far. We would like to hear more on your feedback.
Okay, guys. Thank you for the great talk. We are now ready for the Q&A session. Do we have any questions from the audience on YouTube, in Zoom, anywhere else? Okay, guys. Thank you for okay. I'm checking my notes and I don't see any questions. Is that correct, or should we let the audience rest? If anyone on Zoom wants to ask the questions live, please raise your hand and I will give you the microphone. Okay, that's surprising. Okay, I will ask the question then. Guys, do you plan to extend this work somewhere else, to some other platforms, to IoT or to iOS? I don't know. It looks like something that could scale.
Sure. So what we have planned right now in our minds is to actually add some more findings that are more realistic than the CTF ones, so that the ones that who are learning right now about the Android security, at least specifically,
they'll get more exposure to how and what are the threats that need to be checked, and they could again come up with, let's say, threat modeling of some applications that could be that is to be integrated as well. And yeah, we invite all of you whoever wants to contribute to the application, feel free to send us a pull request. We'll work on it and we can make this an app for everyone in the future.
Awesome. Okay, so my strategy of taking fire on myself and letting the audience rest seems to work out. We have the first question. Does the damn vulnerable bank contain all the real world challenges? It's a tricky one. How can you contain all the real world challenges in one product? But please advise.
Sure. So the challenges that we're adding are the real world challenges. That's one thing that we can tell. There are no CTF-like challenges, or we are not luring the attackers in some rabbit holes. So yeah, and we are going to keep on adding some of the challenges, as well as we'll be adding some of the mitigations that people are using right now, like using some native libraries, and even how to bypass these mitigations as well. So we are trying to keep it as real as possible. Yeah. I'm glad you're on mute if you're speaking.
Yeah, sorry. I'm giving the microphone to Bogdan, who has a question and wants to ask it live. Please go on, Bogdan.
Yeah, hi guys, thanks a lot for your talk. Let me introduce myself. I'm Bogdan, I was Untitled Chapter leader, and I have a question for you. Would it be easier to use real device with Magisk, for example, to bypass root detection and some SSL kill switch to decrypt the traffic?
Hey Bogdan, thank you for your question. So I mean, majority of the applications can be bypassed using Magisk to bypass root detection, and even SSL kill switches work. But in real life or in real world, we've seen applications on which these general tools don't work. So just for that, what we have done is we have implemented, or we've used FIDA, so that the people who are just entering into Android security would also get a taste of it, so that they can use their own creativity in order to write some code to hook into the methods dynamically and perform some more stuff.
Okay, got it. Thank you. Thanks for an answer.
Yes. Thank you.
Okay, next question. As far as I understand, this app doesn't use ARM trust zone. What can you do in such case?
I'm sorry, I'm not able to see the question. Can you please repeat it again?
As far as I understand, this app doesn't use ARM trust zone. What can you do in such cases? I think it means that what you can do when in the cases when the application does use ARM trust zone.
I'm not sure exactly what the question. I mean, what exactly are they expecting it from the question? I mean, if we are not implementing it,
I will ask Alexander to clarify their question if they can,
yes,
or
please.
maybe ask it live, because this is the question from Zoom. Yes, Alexander, you can now talk. Please unmute and go on.
Hello, everyone. Let me clarify my question. So ARM Trustzone is a standard mechanism for security extensions, and it should enhance security for device for using secure storage, cryptography from Trustzone, and other mechanisms. Could you bypass such mechanism with your techniques?
Got it. Thank you for asking.
Excuse me, just from my understanding, it's like security enclave in iOS, right?
Right.
So TPM basically. Yeah, thank you for the question.
Yes.
Really interesting.
Right. So if you're speaking about some of the security measures that are being actually implemented on a hardware level, they won't be bypassed using the techniques, since like even to give an example of Android key store, so correct me if I'm wrong, so even key store cannot be bypassed even on the rooted devices, because unless and until we get the UID or the ID of the application, we won't be able to access the key store that is being actually mapped for the application. So these are the shortcomings of actually hacking the applications, even if we are doing it on a rooted device, or even if the application is running on a rooted device.
Thank you.
Yes, thank you.
Okay, do we have any more questions? We have a lot of feedback, positive cheering on YouTube. Thank you for the great talk. Nice one. Keep it going. Yeah. I would just repeat that if anyone in the audience wants to contribute to the project, get back to our speakers after the talk or after the conference, and
Could I post the link in the chat? Can you go ahead and do that? All right then.
yeah, you can easily find the Invulnerable Bank on GitHub. So your PRs are warmly welcome.
Absolutely.
Okay, any more questions? We have some delay with YouTube. Let's wait for about 20 seconds and then wrap it up. And the link goes to YouTube channel as well. Okay, gentlemen, I think that was a pause long enough for us to be sure that all the questions were answered. Thank you very much for the great talk, and we will get back to you regarding the logistics later on. Okay.
Thank you, Vlad. Thank you for having us.
Thank you.
Thank you,
very
Vlad.
much for your contribution.
Thank you, everyone.
And the great project that you are maintaining. And I again welcome everyone to contribute and join this great opportunity to advance the security knowledge around Android platform.